Hello everyone. My name is Naveen Vashist and I am going to explain about the data science paper question 1 of internal learning. We have three commonly used statistical measures to characterize dispersion in complaint-derived scores. Discuss how these measures can be computed efficiently over large complaint repositories, partition stores, streaming, aggregation, approximate sketches. On this page, we are looking at our first dispersion measure, variance and standard deviation. Variance tells us how far the values are separated from the mean, and the standard deviation is simply the square root of the variance, which makes it easier to interpret because it's in the same units as the original data. If the standard deviation is high, it means the scores are widely spread out. If it's low, the scores are clustered near the mean. This measure works great when the distributed is symmetric or roughly normal. And here you can see the basic formulas for calculating the mean, variance and standard deviation. So now let's talk about how we compute variance efficiently when the dataset is very large. First, we use Welford's online algorithm which let us update the mean and variance in a single pass. This makes it perfect for streaming data and it uses only constant memory. For distributed systems, each partition computes its own count mean and M2 value, which is the sum of the squared deviation. When we merge two partitions, we use this combination formula to get a combined mean and combined variance without reprocessing the full data. This method works very well when the parallel systems like map reduces path. Interquartile range. IQR is calculated as Q3 minus Q1, that's the 75th percentile minus the 25th percentile. It tells us how spread out the middle 50% of the data is. IQR is especially useful when the distribution is skewed or when there are outliers because it focuses on the central portion of the dataset and ignores extreme values. Efficient computation at scale. To compute IQR at large scale, sorting the full dataset works only when the dataset is small enough. For big distributed datasets, we can use extremely sorting or quantile algorithms like Spark, Approx, Quantile if we need extract results. But for large real-world repositories, quantile sketches are best option. Technique like T-Digest, KLL sketch, or GK-based method allow us to compute Q1 and Q3 with very high accuracy using very little memory. Each partition builds its own sketch and then all sketches are merged. From this merged sketch, we use to get the 25th and 75th percentile. Median absolute division. MAD is calculated by taking the median of the absolute difference between each value and the dataset's median. The best thing about the MAD is that it's extremely robust to outliers and skewed data. Unlike standard deviation, a few extreme complaints won't distort MAD, so it's a great choice when we want a stable and interpretable measure. To compute efficiently MAD. To compute MAD efficiently at scale, two medians are needed, the data median and the median of the absolute deviation. The process typically uses two passes. First, estimate the median using a quantile sketch like T-Digest or KLL. Second, compute absolute division xi minus m and use another sketch to find their median. Through single pass method exists, they are less accurate since the median can shift. In distributed systems, each partition builds and merges sketches to find the global median, then repeats the process for deviation for faster but approximate results. So scaled IQR can substitute for MAD. Thank you.